Good morning, everyone, and welcome to OSUIT. I'm Levi Wright, and today we're doing another live virtual tour here with the Instrumentation Engineering program to hear about what a student's time will look like and all of the engineering opportunities here at OSUIT. So, as usual, if you have any questions, please put those in the comments because we want to make sure we get those answered for you as we're live. Even if you're watching this later on and we're no longer live, you can still put questions in the comments and we will still get that information out to you. If you have any friends or family that you think would benefit from seeing this, please share it with them so that they're able to enjoy this information as well. With that being said, I'm going to go ahead and turn it over to Daryl Cunningham and let him take over. Daryl?
Hello everybody, my name is Daryl Cunningham and I am one of the lead instructors here in the Instrumentation Engineering Technology program. We have 3 degree plans here. One is an associate's degree in Electrical Electronics Engineering Technology. We have an associate's degree in Instrumentation Engineering Technology, and also a bachelor's degree that leads into, also in Instrumentation Engineering Technology. Then we're going to focus on those courses, introduce them to you as we go through this tour. I wanted to introduce you to all of our faculty first. So with that said, to my right is Mark Threadgill. To Mark's right is Michael Williams. And back to my left, our newest member, Amanda Cullum, and our assistant dean, Jeff Cushing. And with that, we're going to, well actually, I want to start off telling you a little bit about what instrumentation engineering technology is, because that tends to be a confusing term to many people. And so, in its simplest form, instrumentation engineering technology is something like automation and controls only for the process industry. And so when you think of the robotics industry or mechatronics that you hear commonly in the world, those are the terms that we're really messing with here, except we're focusing on that along with the instrumentation that we use to measure and automate all of that. So with that said, we're going to move to the first room and show you what we do in some of our coursework. So let's go over here. In this room, as you look around, we have 2 rooms adjoining each other here. In all of our classrooms, you notice we have a theory section and a lab section together in the class. The idea is that we can transition from theory right into lab on the go instead of having to reschedule them at separate times. This particular classroom, we teach 2 courses. One's called Introduction to Programmable Logic Controllers. The other one is Programmable Logic Controller Applications. Both of those courses build on each other. The first one we use simulation software to show them how to actually create a software program that controls the automation and the equipment that we're using in industry. The second class applies it in a more practical application. For example, this cabinet right here is a cabinet where the students actually, they don't just program, they actually come in and this cabinet's empty when they start. They have to create an AutoCAD drawing, so they have to take an AutoCAD course. How they're going to wire this, they come in and wire it. After we approve for the wiring, they get to turn it on and start programming. But they get to actually hook all this up. So each student gets their own cabinet. Okay. Once they do that, here's an example of something they might create. Okay. So we got a screen here, and you'll like this one because they like to tease me a lot as a faculty member here. So let me show you what we got. Okay. Here is a program one of my students wrote just last semester. Okay. And in it, all he was supposed to do was monitor pressure, and as it got to certain levels, trigger certain alarms. We have manual lights that turn on, and then we have virtual lights that turn on up here and give us an alarm if we reach a certain threshold at a certain point in time. For example, as I increase this dial here, simulating pressure increasing, here's a pressure level increase. At the same time, in the actual program, I see that level increase also. Okay, so you'll see this one come on when I increase to 20 pounds per square inch. So as I increase a little more, that light came on. You still see this one go up. That one came on. Okay. Then we're going to do a third one and a fourth one, and you'll start seeing color changes indicating levels of risk. Okay. So there's 30 psi, 40 psi. Notice we got a little issue up here now saying we've reached a level that we can't maintain for a very long period of time, and if we exceed that amount of time, I get an alarm. Yeah, they decided I've got a blood pressure problem, and they called the nurse. So, but you can see all this happening. What happened is when I hit the red mark here, got a little timer here that started counting in 1 second increments for 10 seconds, and at the 10-second mark it triggered. Now, if I want to reset this after everything's back to normal, I simply hit a reset button, everything's back to normal, and I'm back monitoring again. That's an example of some of the things we do in our PLC applications class. And we progressively make these labs harder and harder as we go. So everything builds on each other as we go. I'm going to show you an example of an advanced application where they actually made a piece of equipment work. And even though this is in this room, this was a capstone project, okay, which is an end-of-term project. They took a PLC, programmable logic controller, HMI, manual controls, and made this pneumatic system operate. Okay. The whole idea is it detects a device in the tray here, uses air and a suction cup to pick it up, and I accidentally activated it. Okay. Drops it on the conveyor. The conveyor sorts it based on its color. So I'm going to have to drop a puck to get the activation stopped. Okay, so here we go. I want to do a manual operation. Puck comes out, air sucks it up, drops it on the conveyor, conveyor sees it's red, drops it down that tray. Okay, and it just keeps checking. But students had to figure out, how do I make these pneumatic devices create an electronic signal I can use to activate and tell it what to do. Okay, so we got pneumatics and electrical together, controlling this. Very common application in industry. Okay. This was a fun project to work on, by the way. I enjoyed it. So with that said, let's go to the next room. And I'm going to turn this one over to Mark Threadgill and Michael Williams.
Well, good morning. So glad you joined us today here. Today I get to talk about this exciting course about motors and controls. Right here at OSUIT, it's all about applied technology. Right, besides just the textbook and the learning, it's actually applied technology. Okay, tell you just a short little bit about myself. Along with the other faculty here teaching this program, we all have industry experience. Higher degrees in education, completed a master's degree or on the way to completing a master's degree, and myself having over, it's around 30 years industry experience, and then besides, higher degrees in education there, right? And also I think I'm coming up on about 10 years of teaching experience, right? So, okay, so we're going to talk about motors and controls. This is electrical motors and controls. Just to kind of give you an idea of what we'll be doing, here's what we call a relay logic diagram. Here's a diagram of it. We show you how to do that. Right? This is a big thing in industry. It's a big skill of knowing how to go from this to that back here, which we'll be showing you. So here's a wiring diagram. This is 120 volt, what we call a control circuit. Down here is the power circuit. So actually, we have this control circuit controlling the power circuit. Okay, for today's demonstration, what we're going to have is kind of a start-stop circuit, which operates a contactor, which closes some contacts down here, which then turns on a motor, a three-phase motor. This is single-phase 120 volts. This is a three-phase motor down here, okay? So if we can step right back here, we show you where we've actually got a circuit wired up, okay? And before we actually turn on any power, here at OSUIT, along with industry, we're all about safety, right? So anytime that we're wiring up a circuit, we're going to be putting power to the circuit, we have our safety glasses that we put on, right? What we teach here is a skill that you'll need out in industry, and it's called a Lockout Tag Out, and that's part of the safety, right? So right now I have a circuit in operation here, but I don't have any power going to the circuit, right? It's controlled up here, but we look here, there's no way anyone can actually get into this, right? They can not actually put power to the circuit unless they have a key to that lock, right? So that's what we call lockout tag out. And what we'll do sometimes out in industry particularly, we'll not only have a lockout, but then we'll have a tag on here, do not operate, danger, right? Because there may be, physical damage or, injury, right? If somebody is working on a circuit, okay? So let's see how this works, okay? And all of our students will learn how to actually wire the circuit up, okay? And tell you what, it's a lot of fun. The students really enjoy this, okay? Moving the lock. Now, there's a special hasp that goes on there to lock on it, okay? So actually, only now, will I be able to put power to the circuit, but we've got another protection thing down here, which is some circuit breakers, which in case occasionally if there's some problem out here, something shorts out, we'll trip one of these circuit breakers and remove power from the circuit, okay? So let's take a look at this, all right? Whenever I turn this on, the way the circuit operates up on the board here is when the motor is off, a red light will come on, so it's going to stop. And whenever I press the start button, we'll see here, here's the stop button, and then here's the start. And we'll see that the green run light will come on, and then the motor will energize. There you go. The simple start-stop circuit. See, it's operating, and this is three-phase power. We have single-phase power with the control circuit controlling a contactor, which then puts power to our motor, okay? This is one of the simpler circuits that we're talking about. Start-stop, we have a forward and reverse. Maybe want to go in the forward direction, or switch the motor, to go in the reverse direction. We can include different things in there, from a timer to keep it from going from in the forward to instantly in reverse. You want there to maybe be a 60-second delay time till it spins down, right? So all kinds of the variations in this. And we see we've got several stations lined up here, all along here, all the way down here. So we've got plenty of equipment. And I'll tell you, the students really, really enjoy motors and controls along with the other courses here, because you're actually doing something. You're not just reading something in the book, you're looking in the book, but then we're transferring that knowledge to actually hands-on tactical applications here. All right, Michael, I believe he's going to talk about another couple of exciting courses that we have here.
Hey guys, my name is Michael Williams, as Daryl Cunningham and Mark Threadgill introduced me as. Today I'm going to talk to you a little about our class called ECD, or Electrical Devices Control, and our power distribution class. So to start over here, this is what's called the VFD, or a variable frequency drive. With this, you can relate it to an everyday thing like a trolling motor on a boat. Everybody knows what a trolling motor on a boat does, right? You hit a button, it speeds up. It takes a little bit of time for it to get up to speed, right? And then it slows back down, or you can change directions. But how does it do that? All right, so we have our students program this VFD right here to go in reverse, to go forward, to ramp up speed, to slow down, and we can hit this button right here that says direction, stop, and start. So if you want to get in closer right here, you can see the frequency. It's measured in hertz. So if I hit this start button, you can see the frequency ramp up to 60 hertz. And that's going to be full speed of this motor down here. If you can see it running, this shaft right here spinning. Alright, so I'll push this direction button, and it's going to slow down, and then pick up again, and it's going the opposite direction. So this is a sample of what we have our students get into when they get into the ECD class. To transition into our power distribution class is, I'm going to stop this transformer right here. So if you wonder how the electricity gets into your houses, or how much electricity gets into your house, this transformer steps the electricity down from the lines into your house. So we have our students have a good reasoning of how this works and the process in which it goes into. So this will step down the electric into your house to 240 volts. And some of your appliances use 120 volts. But how much do you use? How do you know how much you're using throughout the day? This is what we use right here. These are voltmeters. So these voltmeters, our students get in these and they can program to see how much volts or how much electricity is being used throughout the day, throughout the year. They can get up to specifics, and they get in and they program certain specific points that they want to get into. From that, I'm going to transition to Mark Cunningham and Mark Threadgill and Daryl Cunningham into our next room. Mark is going to be talking to you about hydraulics, and he is right here.
Well, hello again. I get to talk about another exciting course that we have here at OSUIT. I love teaching this course along with the other courses there. This hydraulics, I mean, yeah, it's fantastic there. Yeah, we're using what we do is stay up with the latest, greatest information that's, continually updating course materials. In fact, this is a brand new book we're going to be spec'd out. I'm going to start using this term just to upgrade our program, right? So what we're covering in the courses is really not, old, outdated technology. It's technology of the here and now that you learn this and then immediately go out in the field, right? So, fantastic. All right, so with hydraulics, what we do is we have a lecture, okay, and talking about the principles of hydraulics. It's where pressure, force, and area all come together, right? And then what we find is it's very similar to basic electronic circuits, except that instead of a current, an electrical current, we have a hydraulic fluid moving through the system. Where we have pressure, it creates a force, over an area, okay? And for one of these, if we could see that, we'll take a look at some of this. This is kind of a little circuit that my students build up, okay? And in one of the labs, so we do a lab, we do kind of a simulation lab in Automation Studio is what we call it. I know a lot of these, it's not going to make any sense, all right? There's certain symbols, graphical symbols, that we pull into our circuit, and then we build a circuit that you can actually simulate, okay? I've got a pump here that's driving hydraulic fluid. Here I'm measuring the flow. I've got a pressure relief valve over here. I have a directional control valve here, which will actually control the direction of what this is out here. It's a hydraulic motor, right? It'll spin in one direction or the other, right? And then we've got some flow meters in here too, right? And this little symbol here, flow control valve, okay? So let's see how this works. And my students really love this. We'll talk about the theory and this, hey, let's build something, let's simulate it and see how it works, okay? So I'll go up here and I'll click run, okay? And the red is a high pressure and the blue is low pressure in the system, right? And it's hydraulic fluid moving throughout the system, okay? And we see that our hydraulic motor over there is turning in one direction, okay? So now, this is a directional control valve here. See how I've stopped it? There's no flow going to our hydraulic motor. And then whenever we click this here, we can actually see, yeah, going in the opposite direction. Right. What the cool thing is with all of our courses, it's how hydraulic fits in with all the other courses here. Motors and controls. One section in the course I teach right at the very end is how we can have electrical motor and controls controlling a valve, directional control valve. Instead of operating manually, we can push a button and then it will control the direction of the flow, right? So it's a melding of electrical motors and controls with mechanical, electrical with mechanical, right? It makes for a really cool operation. If you can learn both of these, which any student will coming through the program, you go out in the industry, very, very valuable skills, all right? Okay, I think at this point I'm going to turn it over to Daryl. He's got some other exciting courses to talk about in our program.
Hello again, guys. We are in the room, this room and the next room we're going to be in are where we teach the majority of our advanced or upper level courses. This course, or this room, has 4 other courses we teach in it. One of them is project management. We teach that course. It's basically a theory-only class where everybody's basically on these computers here, and they're learning how to manage projects using software platforms similar to Microsoft Project. And the reason we provide that course is because in our industry, there are a lot of projects that you're going to be assigned to. You may eventually even be the team lead, so you need to understand the concept of how a project works. So we teach that course. We also teach a course called heat transfer and a course called liquid and gas flow, because we're in the instrumentation industry. We're working with flow, pressure, temperature, level. Those are all different things that we have to monitor as part of our instrumentation role. And so we have to understand how heat transfer works, how heat works in a boiler, even in an air conditioning system. We need to understand how liquid and gas flow through a pipe, some of the dynamics around that. And then once you take those courses, one of the last semester courses before your internship, you're going to take a course called Distributed Control Systems. We just changed the name of that course. It is now called Process Management. And the reason is because DCS was a one piece of equipment category. We now teach about 4 different categories of topics in that course, so we had to change the name to fit what we're really doing. DCS stands for Distributed Control System. A distributed control system is kind of like a master system inside a factory, and it's designed to control all the little pieces together and make them work together. We also teach something called SCADA. SCADA stands for Supervisory Control and Data Acquisition. That is something that's primarily used in the oil and gas or the wastewater industry, and it is something where they've got a central control and it's monitoring things happening at different locations around a geographical area. For example, in oil and gas, I've got a bunch of tank farms located out in the country. I need to gather data from those tank farms, but they all get sent to a central location. And that, a good example is One Oak in Tulsa. They have their SCADA center downtown Tulsa, and it monitors tank farms, gas level, flow through pipes. They can monitor the pipelines throughout the nation from that one location. So we teach how that system works. We've also taken some advanced communications because we have to teach industrial networks. How do we make all this stuff communicate together? And so we've done that here. Remember the PLC we learned about in the previous classroom? Well, we have more PLCs. So the PLC is the fundamental building block of the whole program. So once you learn it, we teach you more, we introduce you to different brands, more advanced features, and so that's in here. We get advanced equipment. Remember the variable frequency drives? Well, we get into advanced drives in here. Okay? What you saw in that room, this one doesn't look that much different. Seems like it's an awful empty cabinet, but that little piece of equipment, it can do about 20 to 30 times more than the one you saw in the other room. It's a much more advanced piece of equipment. It's got a display out here I can control from. The other thing that's different about it, excuse me, is that what we had in that room was run off of 208 volts. This one runs off of 480. Anything 480 we have to keep locked out at all times unless when it's operating. So that's why you see lockout tag out here, just like you did in the other room. Okay. We also have a more advanced drive. This one's called a servo drive. It is designed for fast stopping and starting of motors and precision control. These things are not cheap. This probably cost us $3,000. Okay? And this is the small one. Okay? But we get these, we teach them how to use this equipment in the appropriate applications. A good example is right here, conveyor system. Servos are used in conveyor systems all the time. Okay? Excuse me. And this one is designed so that we drop a product here, we can control the speed. The motor over here has a gearbox on it. This is an encoder that knows how many revolutions that motor's made, so it knows where it's at on the conveyor. I got a camera that sees it, and when it drops down here, and we'll control this one and tell it to start moving once it detects a product. Cameras are becoming very, very common in industry, so you see that as an example here. This cabinet is part of what controls this. Now there's a lot in here, but the only part we're really using for these conveyors is this PLC, these two variable frequency drives. Okay. In the other room we had ABB brand, these are Siemens brand, these are Rockwell Automation brand. So you can see that we mix and match, you get to experience multiple brands of products. Okay. But the students built this and designed this as one of their capstones. These are some of the things they work with. This cabinet is a DCS system. Okay? So they get to experience the DCS. Let me walk over here, I'll show you another part of that. Okay? Doesn't look like a whole lot, but this is a gateway. This is actually an antenna, and I use this to wirelessly communicate from this to another piece of equipment somewhere remotely. It'll have the receiver on the other end, and I can actually control something else from this using this gateway. Okay? Now, most people, when they think of a gateway or they think of a router, and you see these nice little plastic boxes, those are home. We have to, in the industrial world, we got codes that we have to follow, standards. This is in a cast iron casing that is explosion proof, simply because it's going to be put in an environment that's hazardous. Okay? So just examples of some of the stuff we work with. And then when we have stuff that is just too big, just too expensive to work with, we get to play around with simulation. So I'm going to show you one simulation, and then we're going to move to another room. this computer, we have a piece of software that literally allows me to come into a blank factory floor, and I can create a factory right here on this floor where I've got anything from tanks to trying to find a good one here for you. Here's a tank. Okay. I can literally drag that tank there, zoom in, hook up controls to it, and physically hook up a real PLC, not a simulated PLC, a real PLC to this, and control that from my real PLC in a simulated environment. I can create, just to give you an example here, there is a great tutorial right here. I'm sorry, let me go back. I'm on the wrong line. If we go down here to this sorting diagram, this gives you a feel for something we can do. Okay. These are the kinds of things we can build inside of this simulation package as to help people get a feel for the bigger environment, because again, factories can afford this, but it's hard to justify the cost of this at an educational institution. So being able to simulate it from a real piece of equipment is pretty cool. Okay? And that is the simulation software. Now, let's move to the last room. This last room, I call it the playroom. So we got a lot of cool stuff. And this is where everybody gets to put everything together and start building their own projects. So let's move on down there. I'm going to turn this over to Jeff Cushing.
Hey guys, girls, hey everybody. I'm Jeff. I'm going to take you through a couple of the courses you'll find that you'll get to take in the bachelor's program. So the very first course is going to be the instrumentation course. So instrumentation basically refers to the hardware and the software and the electronics that we use to measure our environment or the surroundings, of a process or some kind of automation process. So if you look over here to the right, this is a selection of instruments, and they measure a lot of different things, primarily temperature, level, pressure, and flow. So for example, this device measures temperature, this measures pressure, this one measures flow, as is this one and this one, and the big tall one back there in the back, that one measures level. Now you're not just going to learn what these are, you're going to get to learn about the physics of them too. So for example, this flow meter right here uses the principle of ultrasonic physics in order to measure flow. This one uses a turbine that you can see if you get down in there close, and it produces pulses that we use, and we count those pulses to measure flow that way. And this one uses the physics of the Coriolis effect. That's Coriolis. I'll let you guys look that up on your own later, okay? But it's pretty cool. So you're going to learn about all the instruments, how they work, what makes them tick, how to interface them to other devices. So as part of the instrumentation program, you're going to have to learn how to do process automation. So those instruments have to be interfaced with controllers, things like that. Things like this. So this is what we call a PLC, or programmable logic controller. You guys learned or saw that back there a little bit ago. So what we're going to do is we're going to interface these instruments to these controllers, measure their signals, make some kind of a decision based upon the program that you write, and then we can turn on pumps, we can close valves, we can do all kinds of really cool stuff, which you'll see here in just a second. Okay? So there are lots of different types of controllers. There are basic controllers, there are flow computers. You'll also get to program what we refer to as HMIs, you might know as touchscreens. That's pretty cool as well too. So with that knowledge, so once you get that knowledge of instruments, controllers, programming, building HMI screens, you get to put it all together. And that's the process measurement control course. So in that course, you're going to take all the knowledge that you have, the skills that you've gained, and you're going to put it all together. First thing we're going to do is we're going to set you loose on some of these trainers, right? And these trainers are basically our basic process trainers, where you can see we've got some instruments down here. We're measuring pressure, we're measuring level, and we've got a couple of valves, or I'm sorry, a couple of pumps. And so what you'll do is you'll measure the pressure and the level of the water in these tanks, and then you'll turn on and off these valves in order to reach a certain set point. Now, in order to do that, of course, you've got to write a program, and the program is going to be loaded into this PLC right here. And so you'll get to learn how to wire everything, how to connect everything, and once you've got that, then you've got this HMI or this touch screen that you'll get to program, and then you can actually put the buttons on the screen to make this thing operate. So this is just a couple of the process measurement skids that you'll get to play with, basically. And once you go through the process measurement class, then we're going to try to bring everything together. So everything you've learned from day one, the electronics, the programming, the hardware, the software, everything, we're going to try to bring it together in the capstone class. The capstone class is basically a team building class where you're going to take principles of project management that you learned in project management course, and then you are going to build something. So I'd like to show you just a few of the things that our past capstone classes have built. So for example, this is a student project. This was a capstone class a few semesters ago. It's essentially something we call a meter run. You'll find something like this in the oil field. It measures natural gas flow. And you can see that there's quite a bit of instrumentation on this guy. You can also see that it's got a different type of controller, which is something that we pride ourselves on, and we try to make sure that happens, is that you get training and you develop skills on not just one piece or one type of equipment, but lots of different types of equipment, lots of different products from lots of different manufacturers. So as a capstone class, I think 3 students worked on this. They built it from scratch. I mean, none of this was a kit. They had to design it. They had to write the specifications. They had to figure out how this thing is going to work, and then they had to write a program to make it work. And as you can see, they were very, very successful. Another capstone class. This is basically a mixing trainer, if you will. So it's kind of like those over there, in that we've got a couple of tanks of water. Water's going to flow from one tank to another. We're going to have preset levels, and students had to program this as well. Then we get to some of the really cool capstone stuff. Okay, now these are cool, right? Yeah, I think so. I think you're going to like these. So if you come over here to the right, this is a line of other capstones. These over here were the process measurements. These are kind of the mechatronics, the robotic stuff. So this guy right here is actually a heat exchanger that a group of capstone students built under a National Science Foundation grant. It's pretty cool. If you get on in there, you can see how complicated that looks. If you're impressed by complicated things, you'll like that. Students built that. Next is this little guy right here. It looks small, like he doesn't have that much of a weight as far as this line of cool stuff, but this guy is known as Dodgebot. So you see the little hat on? Underneath there are 4 radar elements. There's ultrasonic sensors around it as well. We built it so that you could throw a soccer ball at it, it would see it coming, and it would get out of the way. Works great. It's really, really cool. Next, we have this guy. I think everybody probably knows what a go-kart is. But you'll notice there's no seat, there's no steering wheel, nobody's getting in this thing. It's all remote control. We actually, at one point, this has actually been a platform for a lot of different capstone projects. At one point, we were using GPS to control this thing. We would put in GPS coordinates, and this guy would follow whatever path it needed to follow to get to that particular GPS site. Next, we have this. Yeah, it's a cannon. It shoots air. It just has air in it, though. But it's really, really powerful. This is actually a project that was built as part of a larger project a couple of years ago. We had students who built a tracked vehicle about the size of that go-kart. And that tracked vehicle weighed about 700 pounds, and this guy sat on top of it. And initially, this air cannon was semi-automatic, meaning that we had multiple air canisters underneath, and every time it would fire a shot, a t-shirt, just t-shirts, right? Okay. Fire a shot, it would load the next charge so we could fire another t-shirt. So it was pretty cool. And as you can see, this takes a lot of skill, a lot of knowledge. It's obviously fun, and this is one of the mechatronics projects that students have. So all of this that I've shown you is basically to culminate in developing skills, knowledge, expertise, building a network, making friends, making a team that will help you to get a job, right? And the job that you want to get is going to use all this stuff, right? I mean, instrumentation technicians are everywhere. They're not just in the oil field. They're in chemical plants. They're in refineries. They're food processing. They're in any kind of automation, any kind of manufacturing. You're going to find I&E techs. And so with that, I need to bring you right back here to Daryl, and he's going to tell you about employment and exploration.
Exploration, like space exploration?
That's part of it, man.
At the end of our program, the students go on an internship, and one of the requirements for that internship is for them to take an employment class in our program. That employment class actually prepares them for the skills they need to create resumes, do the interviews, the follow-up, to find a location to go work for on their internships. And so we spend a lot of time on that. And inside that, we teach them other things like networking, you know, the importance of connecting with different people, because in the real world, knowing people has a lot to do with your ability to get jobs. Okay? So we teach them that. We teach them soft skills, you know, and that soft skill, it's a word that I don't think is the appropriate word, but it ties to things that people need to be able to do to be successful in their career. And we teach these throughout the program. For example, communication skills, critical thinking and problem solving skills, creativity, thought process, teamwork. A new term that's coming out is something called emotional intelligence as part of your skill set. But you've got to be able to communicate in order to be successful and advance in a career. So we teach those soft skills as part of that in the employment class. And then they get ready, once they've located an internship, they go on internship and they have certain things they do. They get paid while they're going to school for that last semester, and they're getting practical hands-on while they're on the internship. And one of the cool things about this, and this is one of my bragging points for our program, is we have some absolutely wonderful industry partners that we have some strong relationships with that are very supportive of our program. And typically, they're coming in, giving the students advice throughout the program. They're giving the students direction. They give them honest feedback on what they need to be doing in preparation for the career. Just to give you an example, I've got a list of companies that we have partnerships with. Okay? ABB, it's a big international company. We work with a specific branch in Bartlesville, Oklahoma. Phillips 66, a big oil company. Chevron, Shell Oil, Magellan, Plains All-American Pipeline is one of our big supporters. What?
Nothing. Carry on.
Sorry. John Zink and Zico are two big companies that are support companies for a lot of the oil and gas and chemical and manufacturing industries. Kimberly-Clark, paper company. They make Kleenex. And by the way, one of the things I like to tell people is you have a new appreciation for toilet paper when you go tour Kimberly-Clark. Weyerhaeuser is a big company that we actually do sponsorships with. Those are different companies. AEP, OG&E, One Oak, CP Calco, Siemens, Train, all of those are companies, and that's not all of them. Okay? Those are all companies that we do business with, have partnerships with, but I personally work hard to develop relationships with, along with others in our faculty, along with others in our student services here on campus, to develop these relationships. It's a very big, very key part of our success as an institution. If you want to know what you're going to make in a company like this, or with a degree like this, there's many different fields to go into. You got the petroleum industry, the gas industry, you've got paper, you've got wastewater, chemical, you've got pharmaceutical, food, many, many different industries that you can be successful in this program. And in those programs, you typically start making about $25 an hour is average, approximately. We have students going out $25 to $28 on internship. If you're a top student, if you work hard and you be successful, it's nothing to make $32 an hour on an internship. And then these guys, if you go through the bachelor's program, you have the ability to advance very rapidly. I've seen guys take their $32 an hour and go to 42 in a year. Okay? So that's a little bit about our program. Hopefully that gives you a good insight, and if you got any questions at all, we'll be happy to answer them.
Excellent. We do have a couple questions. One is, when we look at a field like this and we look at the COVID time that we've been going through the last few months, is this an essential field, and can students expect to maintain their careers and their jobs during a time like COVID?
Absolutely. Definitely an essential field. Oil and gas is part of the energy. Yeah, energy is crucial to the maintenance of this country. So there is no problem at all with that being an essential.
Excellent. Another one that we had is, what opportunities are there for women in a field like this and a program like this?
Amanda, you want to answer that one?
Hi guys, so yeah, I'm Amanda Cullum. I'm actually an alumni from the program. I graduated in 2010 and I went to go work for Chevron for the past 10 years actually. I've enjoyed it. I was actually the first female at Chevron with my career title. However, since then there's been several females that have went through that still work for Chevron, and I know there's been several females that have went through this program. It's absolutely a female can do it.
Excellent. Daryl, last question. Do you guys have fun in your program?
Oh yes. We have a blast. I have a passion for this stuff. I love doing this. I love the dynamics that the different students and their personalities bring. And so you can see just from the toys we get to play with that we have fun. So yes, it is enjoyable while you're getting an education that's going to take you far.
Excellent. Well, thank you all, to all the instructors, so much for your time today, and thank you all for joining. If you have any questions that you feel were not answered today, please go ahead and put those in the comments, and we will make sure to get with these instructors and get that information back to you. We want to make sure you get all those questions answered. As usual, make sure you're following the Friends of Pete on these platforms of social media so you can see these videos as we go, and make sure to stay safe, stay true to you, and go Pokes.